Assalamu alaikum. My name is Khairul Hassan. I am going to present a topic named validation of a novel protocol for phosphate determination or simultaneous determination of phosphate and arsenic. A Japanese researcher and his co-researcher developed a protocol which is more cheap and more affordable than the existing protocol for detection of arsenic and phosphate simultaneously. So basically, first of all, I want to say that we work in group and we work in yeast response in toxic elements, and we also work in arsenic determination and phosphate determination. So phosphate determination was our secondary goal when we are going to determine the arsenic, because arsenic and phosphate are analogous. They fall in the same group of the periodic table. That is why we want to observe the color difference that is produced during arsenic and phosphate determination. So why phosphate determination is important? Because we know the phosphate group is a atom which exists in our DNA, and phosphate is important for algae growth, and it's a limited nutrient. We know phosphate is a macronutrient. So in drinking water, 1 ppm is the acceptable amount of phosphate, but in industrial level it could be up to 40 ppm. Here I want to mention that to prevent lead poisoning, phosphate is intentionally added to the supply water not to having lead poisoning. So in this protocol, 7 reagent has been used. So every day we have went to the cars, and every day we did the same works, same things repeatedly. We use 7.5 molar sulfuric acid solution, malachite, molybdic acid, and thiosulfate solution, and potassium iodide. Potassium iodide was used for arsenic detection, but sodium thiosulfate was used for phosphate detection. We prepared 3 standard test tube. Test tube 1 was as a control. On the other hand, test tube B was for phosphate detection, and test tube C was arsenic detection. So they provide us a distinct color to identify the difference between the reaction of phosphate, arsenic, and just only phosphate. Here we have prepared a standard solutions prepared standard solution of phosphate for determining the amount of phosphate in provided sample. Here you can see the color gradient that has been produced. Reaction with malachite and molybdic acid, which we call nicknamed by ammo anti-solutions and phosphate. You can clearly see the color gradient has been produced in standard testing. So here is the absorbance and demonstration we have found in using dual spectrum spectrophotometer, dual chamber spectrophotometer. Here the standard curve that we have get from the concentrations of phosphate and versus the absorbance. Here's the result. Basically, I want to mention that the supply sample that is provided to us to check whether there is a presence of phosphate or not. We have get very trace amount of phosphate in the supply sample, which is perhaps collected from the tube and pond water. That is why we have to add intentionally phosphate to check whether the protocol works or not. That is why we intentionally added some phosphate, and when we add phosphate, we see the different result. And for example, when we get the absorbance 0.3, then we extrapolated from the curve there the amount of the phosphate is 2.7 micromolar. So basically, the goal of this protocol developed was to develop a kit. This kit already marketed by those researchers that developed in Japan. They are already small scale in market, but they send this to the cars to validate and to check whether it works in different hands. It's how it's troubleshoot, and is there any problems in the protocols. So in this kit, they inform us that there will have a three tube, and they will keep they will say this solution X. There will have a solution X, and one tube they will add just normal nanopure water. On the other hand, they will add sample water, and tube C they will add sample water. And after adding the water, pure water and phosphate detecting reagents and the phosphate plus arsenic detecting reagent will say different color. And they also inform us that they provide a color gradient strip. After comparing with color gradient strip, the users can easily identify the amount of phosphate and arsenic in the sample. So we was not provided with color gradient strips. That's why we have to use spectrophotometer to quantify the amount of phosphate in the provided sample. So this kit requires 30 minutes time after the adding sample X, which is the which they said is secret, but they secret sample X. So after adding solution X to the sample, after 30 minutes, characteristic color is produced. So we have done same work, ingredient almost same work we also see, and we get almost same results. But here I want to mention that the reagent, we use two types of reagent. One reagent color from Bangladesh and another reagent color from Japan. We see that when we use the reagent from Bangladesh, it's result fluctuates so much, but when we use reagent from Japan, we see better result. I think the purity of the reagent of Japan is too much better than that produced in our country. So after this internship work, what I have understand that research work in a lot of patients. Than anything else, we have to work multiple times again and again, and we get what the problems, what the solutions. So if we really want to work in lab, we have to have patience, and we have to work with great perseverance, and we have to maintain regularity. So thus we can understand how actually research works. So from this internship work, I have learned that if I really want to work in lab, I have to have perseverance. And if this kit is developed, the phosphate and arsenic detection, already in market there is a kit for developing detecting arsenic and phosphate, which is pretty much costly. But this kit, they say that they will be affordable range. So thank you very much for listening this so carefully. So you can ask question.